We're going to skip 3.3 today. And if you remember back to 3.1, we took a regular parabola, which is y equals x squared, and we multiplied it by some number. For instance, 4x squared. What does that graph look like? It's 4 times taller. And I don't really care how accurately you graph it. Something like that. Okay? When you take the test, I would write 4 times taller right there so that I know you understand what's going on. What if I had y equals, I don't know, 2/5 x squared? It's 2/5 as tall. So you take how tall it is and you cut it into 5 pieces, and the tallness is now 2 of those 5 pieces. And if I made it negative, what would that do? It would flip it upside down, so it's shorter than a regular parabola. What number do we switch from short to tall? What's the dividing line? What number can I multiply by? Anything higher than 1 is taller, and anything between 1 and 0 is shorter. Okay? Yeah, bad question. Whew. You all right? Okay. And then in 3.2, we added another piece to this. So we did something like y equals 2x squared minus 6. What did this minus 6 do? It moved the graph down. So 2x squared is a little bit taller, twice as tall, but that negative 6 brings it down to there. That's 7. There we go. Okay. The only piece we're missing is being able to move the graph to the left and to the right. And this is where it gets a little bit tricky because the x's don't work like you would expect. So if I had y equals x plus 1 squared, we're adding 1 to every x value. Before, when I had my x's and y's, every change I did changed the y's. Multiplying made the y's twice as tall, right? Multiplying by a third made the y's shorter. A negative flipped it upside down. Adding or subtracting moved everything up or down. Okay? But anytime you have a transformation on the inside to the x, it works backwards. So you would think, in order to graph this, that I would take the normal x squared and I would move it 1 to the right. But for some reason, and it's kind of complicated, so I'm not going to get into it, every time you make a change to the x, it actually goes in the other direction. So plus 1 moves the graph left 1, which is a little bit weird, but that's just what happens. Yes. So a plus 1 moves at negative 1. Right. So if I had y equals x minus 3 squared, where would that be? I take the normal parabola, and then I shift it 1, 2, 3 units to the right. Do you guys want to know why it is backwards, or do you care? So the reason is that change happens before the squared happens. So let's think about it. What number can I add 1 to and square it and get 0? What number plus 1 squared is 0? Negative. So my normal graph, this is called the vertex. That is at 0, 0. Well, where can I put the graph? What do I need to do to this graph so that something plus 1 squared still gives me 0? And the answer is all of these points over here to the left. Okay, so it's basically asking, where does the graph need to be in order to compensate for what's inside the parentheses. I don't know if that made any sense or not. Okay, so every parabola has either a maximum or a minimum. That point is called the vertex. And like in a triangle, all of those points are called vertexes, but we don't say vertexes, we say vertices. Each one of those is a vertex. So a parabola has a vertex also. It's either the maximum or the minimum. So in this case, the vertex has moved left 1. In this case, the vertex has moved right 3. Okay? And every parabola also has what we call an axis of symmetry. Can I draw a line that splits the parabola into two identical pieces? Where is that line? Oh, yes. So what number can you subtract 3 from and still get 0? Positive 3. Yeah. So it's slightly more that's the really simplified version, but we're not going to get too much more in depth than that. Is there a line, so for this graph right here, is there a line that splits the parabola into two equal pieces? Yeah, right there. What is the equation of that line? So that's this point is -1, 0, but this point right here is -1, 4, and this point right here is -1, -6. It's every single point that has x equals -1. So all we say is the axis of symmetry is x equals -1, because that is the line that hits every single -1 x value. So horizontal lines are y equals, and vertical lines are x equals. So this vertex is at -1, 0, and the axis of symmetry is x equals -1. Now, we need to put all three pieces together. Well, I guess there are 4, because you can flip it upside down too. So let's say I had y equals -3 times x plus 1, let's do x plus 4 squared minus 2. Whoa, lots of stuff going on here. Okay, does it matter what order you do them in? And the answer is yes. You always start on the inside and work your way out. So what happens here? Left 4. Does everybody understand that? So my vertex moves from 0, 0 over to here. Okay. What does the 3 do? Not down 3. Taller. 3 times taller. So we stretch it vertically. What does the negative do? Flips it upside down. And then what does the -2 do? Bring it down 2. Side to side is on the inside with the x, right? X-axis. So the plus 4 is left 4. The 3 means 3 times taller. The negative flips it upside down, and this brings it down 2. So my vertex is here, and it's upside down, and it's very tall. It's 3 times taller. So let me review what happened. So we take our original parabola. Actually, let's do it this way. There's my parabola. I go left 1, 2, 3, 4. Then I make it 3 times taller. And then I flip it upside down. Why is it disappearing? Oh. And now I go down 1, 2. I'm off the page. Okay? So the question will say, where is the vertex? What is the point of the vertex? -4, -2. Okay. And then the axis of symmetry, it's that line right there, x equals -4. Okay. Let's do another one. I think so. So, vertex, axis of symmetry, and graph. Yep. Okay. So what about y equals 1/6 x plus, or x minus 2 squared plus 1? Where do I move first? What does x minus 2 do? Right 2. Oakley, you good with that? So on the inside, it's backwards. So we go right 2. And then we don't say wide, we say short. Good. Yes. Right. Everything in the inside is backwards. Okay, it's 6 times shorter, which means it's super wide. And we need to move it up 1. Oh, that was nice. Okay, do you guys get that? Where is the vertex? The vertex is 2, 1, and the axis of symmetry, x equals 2. The line that divides it in half is called the axis of symmetry. That's where it's symmetric. That's the line that allows you to bend it together and it matches itself. So you would say vertex is 2, 1. Your axis of symmetry is x equals 2 because that's the line that splits the parabola in half. And then you draw the graph. Yeah, you'll have to graph. In fact, we're going to skip half of the assignment because it's stuff that the honors kids need to know and you don't. So, yeah, you'll have to graph them all. Okay, what about this? Y equals 0.4 x squared minus 3. How far left or right do I move it? You don't. How can you tell we don't move it left or right? There's nothing inside the parentheses. Okay. What does the 0.4 do? Taller or shorter? Shorter, because 0.4 is less than 1. Good. What does the minus 3 do? Down 3. So 1, 2, 3, and it's wide. And the vertex is 0, -3. And the axis of symmetry is x equals 0, which is the line right down the middle. Okay, a couple more. What do we do here? Left 4, 7 times longer, and upside down. So we're going to go left, 1, 2, 3, 4, and this one is super tall, and it's upside down. So the axis of symmetry, or sorry, the vertex would be 0, -4. Oh my goodness, that's not right. -4, 0. And then the axis of symmetry is x equals -4. Okay. One more. Okay. So to the right 6, what does 6 over 7 do? A little tiny bit shorter, right? Not much, just a little tiny bit shorter. And the plus 3 moves it up. So if a regular parabola was shaped like this, then this one is just a little tiny bit shorter, not by much. And then I would write the vertex is at 6, 3, and my axis of symmetry is the line x equals 6. All right. So I would like you guys to do um, 31 to 48 all. It's not bad. So on the first set, it says find the vertex and the axis of symmetry and graph. That's pretty simple. And then the next 4, you're just going to match. Which graph is this? Is this A or is this B? Is this C? And then look at 39 through 44. It says graph the function and compare it to the graph of x squared, which means you just describe the movement. So you graph it and you say, I went left 4, up 2, 3 times taller, and it's upside down. Okay? And then 45 through 48. Oh, shoot. Never mind. You don't know how to do that. Stop at 44. Okay. Good luck.